There. All right, let's go and take a look at this example. So our question is this balanced? And this goes for our warm-up question for today. So is this balanced? So to do that, we're going to break this down into its parts. We have A, B, and C. So we have A, B, and C. And on this side, we have A, B, and C as well. All right, so let's go ahead and count them up. This 3 is going to multiply everything that's after it. So if we look at A, it's 3 times 1 here. Get 1 times 3. 1, because there's no number here, times a 3. So we have 3A, 3 times 2. 2 times the 3 in front, 6. And then here it's, there's only 1 C times the 2 in front. So we have 2. So in order for this to be balanced, we need to have 3 A's on this side, 6 on this side, and 2 on this side for A, B, and C. So let's look at it this way. All right, 3 times A, there's only 1. So we should have 3A. 3 times the number of C. So it's 1 times 3. So here's our first problem. These don't match. Oh, sorry. Yeah, they shouldn't match because I'm putting in the wrong spot. Sorry. This is C, right? So it should be down here. So these two don't match. That's our issue. If we look at B, it should be 2 times 1. So we have 2 here. So let's correct that. So B, there's 2 B's. There's 3 C's and 3 A's. So we have 3, 2, 3, 3, 6, 2. So these don't match up. So we can say no, it is not balanced. The amount of B and C are not the same on both sides. So B and C are not the same on both sides, so this is not a balanced equation. If we wanted to, we can balance it by changing the coefficients. So we can make this easily put a 6 here to fix that. And we can easily put a 3 here to fix this. So we can replace these coefficients in order to make it balanced. But in this current case, it's not. Oh, and I'll stop sharing results. All right, so that was our warm-up for today. We have a single displacement reaction that is not balanced. So this would be something if you were going through, you could quite easily check to see if you got the correct answer by just doing this process, checking both sides to make sure the atoms are the same. Once we get good enough, like you can do these quick checks in your head to make sure that both sides are balanced before you write down your answer. So this is the process I want you guys to do before you put your final answer down, is just to make sure that the equation is balanced. All right, so yesterday I had you look at 2 problems that we did not finish in class. Let me go ahead and pull those up and then we can talk about them. All right, so this was 4.4. And yesterday we had you look at problems number 4 and problems number 6. So problems number 4 and 6. So I'm going to put those ones down for us. So number 4, I'm going to put down the correct answers for us so that you guys can check your work and see if we got it right. And number 6, we have Ag2O, Ag plus O2. So for these two problems here, this is what you guys should have gotten yesterday. So number 4, you should have 4 phosphorus, 5 O2. On this side, it's 2 is going to be our coefficient. So if we count it, 4 times 1 is 4, 2 times 2 is 4. So phosphorus is good. 5 times 2 for oxygen is 10. 2 times 5 is 10. So that's balanced. Number 6, we have here, it should be 4 silver. 2 times 2 is 4. 4 times 1 is 4. And then 2 times 1 is 2. And then we have 2 here. So it should be 4, 5, 2 for the coefficients. And then we should have 2, 4, and then nothing here. Does anyone want me to see either of these? I can go through and solve this problem, either of these problems. Remember, when you're working this out, you need to show your work for these. So if you just have this as your answer, that's not good enough. You need to prove to them that they're equal. And when I mean show your work, it's going to be similar to what we did here. Show me that how many of each atom do we have on both sides. If no one wants to see either of these worked out, we can get to today's lesson. So let's go ahead and close this off. Let's go back to today. So today we're on 4.5. We're going to do a second round of balancing. So for part 2 today, we're going to look at how to deal with problems that are a little bit more complicated, and we'll see why they're more complicated in just a second. So one of the things with these problems is it's not always obvious which ones are difficult, which ones are easy. One thing to look out for, though, is if you have the same element in 2 different places. So we have oxygen here and we have oxygen here. Those are a little bit tougher than the other problems. So we're going to learn like a trick today to help us solve these problems. And typically these combustion reactions are a little bit more difficult. But a lot of it's just time and practice. So with time and practice, you can do any of these. All right, so this is going to be example number 1 for today. So this is our problem. We have spaces in front of each of these. I'm going to rewrite this in a sec. So when we have problems like this, notice that oxygen is in 2 separate places. In the products. So we have auction here and we have auction here. One trick is we can deal with this last. So if you have something where you have one element in different places, typically that's kind of harder to balance. So we're going to deal with this last. So let's look at our equation. I'm going to rewrite this so I have space. So I'm leaving myself space for the spaces. So we said that we're going to deal with auction last. So let's take account of everything that we have. So at first count, we have 1 carbon, we have 4 hydrogen, and we have 2 oxygen. Okay, on this side, we're going to keep the same order. So we're going to do carbon, hydrogen, and oxygen. So we have 1 carbon here, 2 hydrogen here. And this is where it's going to be important. If we look at oxygen, we have a total of 3, 2 here and 1 here. But instead of adding these together right now, we're going to write them separately. The reason why is if I put a number in front of here, that's going to change how many oxygen I have total. But it's only going to affect this oxygen, this 2. Same with this one. If I put like a 7 here, I'd have 7 oxygen now. So because it multiplies by 7, but I'm only multiplying this by 7. I'm not multiplying this by 7 or whatever I multiply by. So it's important to keep these 2 separate. So if you have an element in 2 different places, keep it separate for now. We're going to add them together at the end, but you'll see why in just a second. Okay, so our goal, we said we're going to balance oxygen last because it's in 2 separate places. So carbon and carbon are balanced, so we don't worry about that. Hydrogen, we have 4 here, and then we have 2 here. So we need to balance this here. We want both of these to equal 4, so we need to multiply this by 2. So if we multiply this by 2, the only way we can do that is by adding this coefficient 2. Because it's going to be 2 times 2 would give us 4. But this 2 also multiplies this oxygen. So it's going to multiply the single oxygen that we have down here by 2. So you can see why we wrote this separately, right? Because if we put them together, we would be multiplying the whole thing. We're only multiplying this oxygen. So it's going to be 2 here. So we have 4 hydrogen and 4 hydrogen. That's fine. We have 1 carbon and we have 1 carbon. And then if we look at our total here, it's going to be 2 plus 2 because we add these together, right? 2 oxygen here, 2 times 1, 2 oxygen. So 4 plus 2, or sorry, 2 plus 2 would give us 4. So it means on this side, we need to get 4 oxygen. So we're going to put a 2 in front to multiply this out. So we multiply this by 2, we're going to get 4 oxygen here. So we check it. Carbon, 1 and 1. Hydrogen is 4 and 4. Oxygen is 2, and then it's 2 plus 2. We get 4 total. So we add these 2 together. So now both sides of this are equal. So let's just rewrite this so it's nice and clean for us. CH4, we don't include any 1 because we just leave it by itself. We get rid of the blank space. Plus 2O2 gives us CO2 plus 2H2O. That would be our balanced equation down here. So that's kind of our trick, is dealing with elements that are in two separate places. I want you to treat them separately and then add them together at the end when you're checking this off to make sure that they're both balanced and equal. So today you're going to see a few problems like this where we have to deal with one element that's in multiple places on one side of the equation. So this is kind of like our intermediate problem. These are where it starts to get a little bit tougher because we have to keep track of where our count. When it comes to showing your work, I want you to prove to me that both sides are equal. So give me the number of atoms on both sides. To show that the reaction's equal. All right. So what we're going to have you do is we're going to have you try one out on your own. So we're going to look here at problem number 1. Na plus H2O gives us NaOH plus H2. We want to balance this equation here. So for this one here, we have Na plus H2O yields NaOH plus H2. All right, so let's go and take a look at our .chem. So before we do anything, let's split this up into 2 halves. We have our elements Na on the left, Na, H, and O. So we have 1 Na, 2 H, and 1 O. It's 1 Na, 2 H, 1 O. On the other side, we have 1 Na. For H, we have 2 different places. So for H, we have 1 here and we have 1 here. So you have 1 and 2. So it means we have a total of 3. And oxygen, we have 1 here. So if we look, 1 sodium, so that's fine. 1 oxygen, that's fine. 2 hydrogen, but you have the extra, which means we have 3 and 2. This is not balanced. So we try to balance sodium, we try to balance oxygen, they're already balanced. So here's our question, right? We need to make sure that both sides of this equation are the same. Well, this doesn't work, right? Because this is 3. We can't make both sides of this 3. So let's try to do something, right? If we can't make this side's 3, right? If we can't make it 2, let's try to make it 1 bigger. So let's try multiplying this by 2. If we multiply this by 2, we would get 4. And then we can make this side 4 too if we multiply this here by 2. So if we do 2 here, we get 2 plus 2 would be 4. That would make this balanced. So we can take our 2 and put this in front of H2O here. And we can take the 2 and put it in front of NaOH. because this would multiply out to both these, and this would multiply out to all these ones. So let's do that. So this is going to be 2 times 1 for oxygen. So we should get 2 here. For sodium, it's just by itself. Here we have 2 times 1 for sodium, 2 times 1 for oxygen, and then we already did 2 times 1 for hydrogen here. So it's going to be 2, 2. So let's check. Oxygen is 2, oxygen is 2, that's fine. Hydrogen is 4 because it's going to be this if we add them together. 2 plus 2, we get 4 here. So that works. The only one that's messed up is sodium. We need to have 2 on this side. So we put a 2 in front. We should get 2 sodium. So let's see. This is 2 and this is 2. Hydrogen, it's 4 here. On this side, it's 2 times 1, so we get 2. And there's no number in front, so we can just say 2. So we'll just add these 2 together. So we get 4. That way it lines up. So 4 matches, and then oxygen matches as well. So this one's a little bit tougher, right? You get to a point where you're not sure what to do. When in doubt, you could always double things and see if it works out. It's just kind of looking at patterns for this, noticing that this is 3, but we can make both sides the same by making both of them 4 to start off with. So as problems go, this one's a little bit tougher than the rest. So working through the problems today, you should see ones that are a lot simpler coming up. The next couple should be easier. I just want to start with this one so that we have a feel for what to do with some of these more complicated ones. Okay, so we have about 15 minutes left together. What I'd like to do is, so we went through 1. I want you to go through problems 2 and 3. And then we'll have some time to talk about those. So I'll have 5 minutes to work out whatever problem you want to see worked out. And that will leave us with 3 problems for tonight. So let's focus on getting problems 2 and 3 done in class today. And then that'll leave us with 3 problems to finish up tonight.